So welcome to this one, which is question 3 of the integral exercise A-level stats. We're looking at correlation association. We're looking at the extension questions, exercise 3 and question 3. You should have the questions in front of you. So I'm just going to go through this quickly. It says that it is suspected that two quantities Q and W, it is suspected that there is a formula that they're connected and that this is the formula. And then they give you a table of results and it says show that this formula here is equivalent to, and then they give you what they think it's equivalent to, which is in log base 10. So let's just show you quickly how to do that. So I'm going to do log base 10 on both sides. And then you should know the rules here that you if they're multiplied like that, you then add the logs. And what's nice is that they kind of lead you into doing this, which is nice. Oops, lazy. Bring the B down. And you can see that's like the gradient, and you're very, very similar to the y equals a plus bx, isn't it? So it's a straight line. And then it says plot the scatter diagram of log base 10q against log base 10w. So I'm going to pause the video, draw the table up quickly and show you how that fills in. Let's just pause it for a second. So what I've done is I've put most of the table of results here, but I just wanted to show you very quickly how to do it, because you might be thinking, well, how do I put that data in? So I've missed this one out here, which if I go through, it's a third. So I want to put the next one in where it says W is 40. So I literally on my calculator, log base 10, put the 40 in, equals 1.602. And then I put in the Q value. It says it's 31. So I'm just going to go back to put 31 in there. And that's 1.491. And then I would finish off the others. And so then it says to draw a scatter diagram. I then have to plot that. Now I imagine they'd give you a screen like this and you just have to finish off plotting the points. And so I've almost finished off. So let me just finish here. I think the last one is 1.77, which is about 1.8, 1.2, so roughly there. And so that's a scatter diagram done. And then it says estimate the equation of the line of regression by drawing an estimate of the line through the mean point. So I've got to find the mean point and then estimate it. Now, this is a particularly interesting question because what I can do is I can put all the data in my calculator straight away and do it that way, and I can find it using the regression line. I've shown you in a previous question how to do that. But if I wanted to do it in a really weird way and just purely do it in this sense, then this is what I would do. I would first of all have to add up all the W's and divide by how many there were. So I'd get my, let's call this a W, this is my X value here. So my W bar value would be sigma W over, I think there are 8. And if you did that, you come out as 1.4052. And then I would do my mean of Q as well, which would be sigma Q over 8, which if you did it would come out as 1.5164. And then you would plot that point about there. And you could label it X bar, Y bar, or actually W bar, Q bar. You'd label it. And then you'd have to make sure, now this is going to get smudgy, I can tell, but the points would have to go through there, and then you'd have to estimate. Now obviously my diagram is pretty shockingly poor. The other thing as well, your line it starts and ends with the data range here. So I can't go beyond that, but what I can do is I can estimate a value there, and that will give me my estimated value at that point. I then have to try and work out my gradient. I've chosen that point there, so I could just draw a little triangle like that, and I would work out my gradient. So my gradient here is in my y, I'm going from, what was it, that one was 1.204 up to the mean value of 1.5164 all over my x value, which would be 1.778 all the way back to 1.4052. So I would then work that one out. 1.204 minus 1.5. As long as I've done it in the right direction, I don't have to worry about the sign, although I do know it's going to be negative, so that will be a double check for me. And I get a gradient of minus 0.838 roughly. And I think it's not brilliant, but it's roughly about that value there. So roughly about minus 0.8. I think if you did it on your calculator, you'd get to, I think it's minus 0.77. So my estimation skills are pretty bad, but maybe because the diagram isn't very good either. And now I have to, so that is my gradient. So now I know my gradient. So I'm going to just use the formula, which you remember it's y minus y1 equals mx bracket x minus x1. And so what I need to do here is I need to use my mean values. So I'm going to use my mean values. So I've got to do that because these are the most stable ones, and I know the line goes through that as well. And then so I would go along doing that, tidy that all up, and eventually I would get to something close to this. Now, obviously, if I were to do it properly using my calculator, which I don't see why I wouldn't, I would get more accurate data, because that's the whole point of using a calculator, isn't it? And then the final question, it says estimate diagram, I think, is that all the questions asked of? Let's just check quickly. Where are we? Boom, boom, boom. So let me actually, what I'm going to do is pause until I find if there's another part of the question. Right, so the question says estimate A and B. Well, I can see that B here is roughly minus 0.8. So B is roughly minus 0.8, and A, well, I've got, it's 2.63, but remember that is what log 10 base is. So log 10A equals 2.63. So I do I just get rid of that exponentially, and then I can find out what that equals, and hopefully you do find it comes out as 430. And so that's how I would do that. Hopefully that makes sense. Talk to you later.